Hi, this is Dr. Rainey again here for part 2 of the lab. Now we're actually going to do the actual lab, and I'm going to show you how I'm going to do the actual lab. So first we're going to weigh copper sulfate. If I'm going to take you to the copper sulfate. So if you see the copper sulfate here, it's a blue color solid, copper sulfate pentahydrate. It's a blue color solid. We're going to take 6.25 grams of copper sulfate. And we're going to take that 6.25 grams of copper sulfate, and then we're going to add the copper sulfate in the water, in 50 ml of water. So I'm going to dissolve in 50 ml of water, and I'm going to stir it and make sure it's completely dissolved. So now you can see how this the color looks like before the actual reaction starts. So it's a clear, aqueous, clear blue color solution. So that's the first thing you have to write down in your lab book, how it looks like before it reacts. So this is the blue color's copper sulfate solution. Now next, I'm going to show you. I'm going to weigh while it is dissolving. You can weigh iron powder. So I'm going to take the iron powder. So you see the iron powder I'm going to weigh. I weighed 1.4 grams of iron powder. You see how iron powder looks like? It is a gray solid. Iron powder looks like gray solid. So now I'm going to take that iron powder, gray solid, and I'm going to add into the copper sulfate solution. And the reaction going to start. You see how the color will disappear from a blue color solution. It becomes bluish green color solution. So you see I'm going to stir it. So I keep stirring it. You keep stirring till the reaction starts. And you see, so all the iron will become iron 0, it becomes into iron 2 plus. And now it kicks out copper, which is already in copper plus 2 state. It's going to get kicked out in the form of, when it comes out, it becomes copper 0. So can you see the copper reddish brown copper which is forming here? Can you see this? You see it looks like a little bit reddish color. See reddish color, that's the copper which is coming out. Let's see, and you see the color, the intensity of the color, the blue color also disappears once the reaction is over. So I'm going to keep stirring. And if the color persists for a little bit longer, you can add a little bit more of iron. Or in this case here, I'm not going to add. I'm going to see how much ever reaction has happened. I'm going to leave it there itself. And I'm going to keep stirring till all my color. So see how the color is going from a deep blue to almost like a bluish green color, you see? And you see how the copper is coming out. See, if I see the copper, you can see the copper coming out here. So here is the copper coming out. So can you all see? I guess I'm going to put the camera very close to this, and copper, can see the copper, the reddish brown is the copper. And once this copper comes out, so you keep stirring till the reaction is going on. So you keep stirring it. Usually we have to put it on the counter and keep stirring it. So you see how the color is becoming from a dark blue to the color is changing. So that means the reaction is happening. That is one of the indicators of the reaction, the progress of the reaction. And now you see most of the color is almost gone, and you see the very slight bluish color solution is still there. So, and I'm going to stir it for another couple of minutes. And now what I'm going to do is I'm going to decant this into another beaker. And while I'm decanting, I will let it settle first, and then I will decant it. And then I'm going to wash it with water several times. And in meantime, while it's going on, I'm going to weigh, this is an empty petri dish. I'm going to use this, which is also called as evaporating dish. I'm going to weigh this, on the balance, and I'll record the empty weight of this without any copper in it. So once I record it, and then I'm going to transfer the copper after I wash the copper with very little. After I decant, I'm going to put all the copper into this petri dish, and I'm going to wash with acetone. And why I have to use acetone? Acetone is an organic liquid which also acts like a desiccator. It dehydrates. It removes all the water from the mixture. So if anything water remaining, moisture, the acetone has a very low boiling point, and it takes up all the water, and I decant the water, the acetone solution. So as I'm washing a couple of times with acetone, it's removing most of the water. And now what is remaining is already washed copper in it. I'm going to show you that. So you see now reaction is almost finished. So if you can see, this reaction is almost, the blue color is already gone. It's clear. So now I'm going to let it stand. And while you're waiting for copper to stand, I'm going to collect acetone, and I'm going to wash with acetone and see how acetone removes the water. So okay, and then let's see, I'm going to decant now. I'm going to decant in another beaker. So see how I'm decanting. I'm going to decant. While make sure that when you're decanting, make sure there is no solid coming out, falling into the other beaker. And I'm going to add more water, and I'm going to add a little bit more water, and I'm going to wash this copper solution with more water. And I'm going to stir it, and again I'm going to rinse it with copper and let it sit for some time, and then I'm going to decant again. I'll do this couple of times, and so what I'm doing, if there is any excess copper sulfate which is remaining, it will be washed away. So now I only have copper. So you see how clearly you can see the copper coming out. So that's the reaction. So now we're going to, in this experiment, what we're going to see, how many moles of copper sulfate to how many moles of copper is coming out. Not copper sulfate, I'm sorry. With iron powder with copper, we are going to compare. According to the reaction, it has to be 1-to-1 mole ratio. So that's what we're going to find out, whether we are going to get 1-to-1 or not. So I'm going to collect the copper now. So what happened to this solution? So in this solution, all the iron sulfate which is formed, that iron sulfate has gone into the solution, and it's become a clear solution. That's why we write it as aqueous solution, AQ. So all the iron sulfate has gone into this. Now copper is solid. So it's not soluble in water. So it came out as a precipitate. That's why you see the copper is at the base. So now I'm going to decant the second time. See, I'm washing it. So when I'm washing, make sure there is no copper coming out. So you're not wasting anywhere copper. So I'm going to wash it. Now I'm going to, third time, I'm going to wash it with very little water. And I'm going to rinse it. And all this, I'm going to pour it in a beaker now, in this evaporating dish. See how I'm going to transfer into an evaporating dish. And now I still have a little bit more left. So what I'm going to do, I'm going to rinse it back with a little bit water and wash it, everything, transfer into this. And if you have a little bit left, you can add water, excess water, or you can just rinse with the same water. You decant and pour it back. So, but make sure in the process you're not wasting any copper anywhere. So you see now I transferred everything. So I don't have any copper left. You see in this beaker there's no copper left. All the copper is in this evaporating dish. So I can come closer to the evaporating dish. You see all the copper is in the evaporating dish. So now I'm going to, you see what happened? All the copper got kicked out from the, so now I'm going to decant this remaining water again. So if this beaker is full, you can use another beaker. But this is all waste. I can discard. I can throw directly into the sink. But all these are water washings, so I can throw in the sink. But if it is a washing with using acetone, I cannot throw down the sink because acetone is organic solvent. We cannot throw any organic solvents down the sink. We need to collect it back and recycle them. So I'm washing, you see I washed it. And if there is anything, there's a little bit of moisture left, I'm going to wash a little bit again, one more time in this evaporating dish, and then let it settle. And then once it's settled, see how it is there? Once it settles, it's very clean copper. And now I'm going to let it settle, and then I'm going to filter it back. I want to decant it. I hope you all can see this experiment while I'm doing. So see, now I'm going to decant. So while I'm decanting, make sure that I'm not, there's no water, no copper is coming out. So this beaker is full. So what I'm going to do is I'm going to discard some of the water back into this, and this is the waste container. So anyway, so I'm going to use this as my waste container, and make sure that there is no copper going out. Make sure that, so now this is the copper. You're going to dry it with acetone, and then you're going to put it on a hot plate. And once you put it on a hot plate and you dry it, you will get a free-flowing copper solid. So I'm going to put it on a hot plate now. So once I'm going to dry with acetone, so let me show you. I'm going to dry with acetone. So you see I have some acetone here. This is called acetone. I guess the name says acetone. So I'm going to rinse with acetone, and once I'm going to add acetone and rinse with acetone, I'm going to decant. I'm going to stir it and make sure that this is getting dried. Complete acetone is, and then I'm going to decant it back. I'm going to use I'm going to use a different container here, and then I'm going to show all the collecting. I'm going to collect it back because it's an organic solvent. So let me get some acetone. Rinse with acetone. Okay, I poured some, and then I'm going to pour back some acetone here. So now you see you got the rinsed. I completely washed it, and there is no moisture left now. And I have this copper with almost no moisture. This is only an acetone now. So I'm going to take this acetone washed copper and I'm going to place it on a hot plate. So I'm going to place it on a hot plate at a very low temperature. Now I'm going to put it at about close to make it faster. I'm going to put a little bit around 110 or 120. And now you see as it gets hot, so what happens is this copper, if it is too hot, copper gets reacted with the atmosphere oxygen. It forms copper oxide. So I don't want that copper oxide. I need only copper, because that is what is my reaction is coming, kicking reaction I'm getting out. So I don't want copper oxide. So if you have copper oxide, the mass will change and the mole ratio also will change. So I need to have so what is happening now when I increase the temperature, so I'm going to slightly make it to 120 right now, at 125. And so I'm going to stir it. So while it is stirring, what's happening, most of the water will go away. And then eventually what you get is a free-flowing solid in this evaporating dish. And when you take the mass of this evaporating dish along with the copper, and you subtract from the empty mass of the evaporating dish, you will get the mass of the copper. And you can, once you get the mass of the copper, you can calculate the moles of the copper. How do you calculate the moles of the copper? Whatever mass you get, you divide with the molar mass of copper, which is 63.5. So once you get certain amount of copper, you divide by 63.5, you will get the moles of the copper. And now you can compare the moles of the iron. So how much iron I started initially? I started with 1.4 grams of iron. So you can divide 1.4 divided by molar mass of the iron, which is 56. So when you divide that, you will get certain number of moles. And you got the moles of iron, you got the moles of the copper, which is you got from the reaction. So you can compare if it's 1:1 or if it's not 1:1. So this is the reaction about identifying the mole to mole ratio of the reactants and the products. And the reaction what we are doing is the single displacement reaction. Now who is getting displaced? Here copper is getting displaced. So initially what was the oxidation state of copper? Oxidation state of copper is +2. Now it's when it got kicked out, the oxidation state of copper in its free state is 0. So it's going from +2 to 0. So it's decreasing. So decrease in oxidation state is called as reduction. So oxidation state means the charge. So copper initially was +2, it became 0. So it is decrease. So it is undergoing reduction. Now, who is undergoing oxidation? Copper, iron. Initially, what was the charge of iron? Iron was solid in its native state. And so the charge in its native state is 0. Now, iron became what? Iron sulfate. So what is the charge of iron in iron sulfate? It is +2. So iron is going from 0 state to +2. That means the oxidation state or the charge is increased. So increase in oxidation number is called as oxidation. So who is undergoing oxidation? Fe0 is undergoing oxidation. Who is undergoing reduction? Cu+2 is undergoing reduction. Now, how many electrons are involved during this process? Because iron is going from 0 to +2. That means it has how many electrons it is giving away? 2 electrons. So who is taking those 2 electrons? Copper is taking those 2 electrons. So it is going from +2 to 0 state. So how many electrons are involved? Only 2 electrons are involved. So this is all the reaction about molar relationship in a chemical reaction. Thank you for watching, and I hope everybody can finish their labs accordingly. Thank you.